Hello, my name is Rafael Muniz, and this is my presentation of the Machine Learning course at Duke University. In this final module, the focus will be on the area of deep learning. The main objectives are describe the intuition and mathematical principles behind deep learning, identify common applications of deep learning for computer vision, explain the strengths and challenges of deep learning relative to other forms of machine learning. Gain hands-on experience in the process of building and evaluating machine learning models. The project refers to predicting electrical energy production using a regression model, for which the following important steps were necessary. In this project, we will build a model to predict the electrical energy output of a combined cycle power plant. As first step, it is essential to obtain reliable historical data on energy production. For this study, we will have over 9,000 observations. Furthermore, it is necessary to include variables such as temperature, ambient pressure, relative humidity, and exhaust vacuum. And with this information, together with the applied methodology, the objective will be predicted the net hourly electrical output. The two-linear regression models were analyzed using the Microsoft Excel tool, dividing the data into 80% for training, 10% for validation, and 10% for testing. Two models with independent variables were chosen. Model A, with consider the effect of the four variable features, and Model B, which consider only two variables, temperature and exhaust vacuum. On this slide, we have a summary of the criteria that were used in this project, being the main steps for analyzing and interpretation the results. Starting the training of Model A, 80% of the data obtained was used to analyze the first scenario, obtaining in this case a round mean square error of 45.3. When carrying out the validation analysis with the other 10%, a result of 40.48 was obtained for the same index. And when carrying out the third analysis of Module A, the test analyzing in detail the residual difference, absolute value of error, square of error, and absolute values of errors divided by actual value. A very similar result can be found of 40.48.6. Same methodology was used for Model B, where only two features were considered, also the training exercise, validation, and test. This case obtained the round mean square error of 40.48.3. This graph it is possible to demonstrate the comparison between the two models, considering that in this case lower values indicate better performance, as they penalize larger errors. In the case of MAE, it shows that on average the forecast was off by around 365, which may be an acceptable level in this context, while in the MAPE, analysis demands that 0.8% of the variability in the energy production is explained by model variables with is a good performance indicator. And as a result, an interpretation of this project, Model B presents better overall performance considering all metrics, also taking into account the simplicity and interpretability of the model. Thank you for watching this presentation. I hope the analysis carried out have been clarified. Thanks.